Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, we are going to explore one very interesting concept related to AWS Athena, and that is Athena pseudo columns. Okay, not only the concept we will be exploring with practical examples, but I'll be also sharing with you all one backstory where this particular feature of Athena basically helped me in performing root cause analysis for one of the real-time data pipeline and saved me in an escalated situation. Okay, right? So without any further delay, let us try to understand that particular situation first, and then what is the problem occurred in that situation and what I was asked to analyze, that also I will explain, and then how this particular feature of Athena helped me in resolving that issue, that also I will walk through. So let's first try to understand how our real-time data pipeline was looking like. Okay. So here I have basically drawn the architecture diagram for one of our data pipeline in which I have worked end to end in my one of the previous organization. So I was working for one of banking domain client in the marketing team, and one of the major project in which I was assigned is building a real-time marketing campaign platform. Okay, that is whenever a customer is doing some transaction, that can be UPI, that can be IMPS, that can be RTGS, that can be NEFT, etc. Various kind of transaction a customer generally perform. Now based on these different categories of transaction, different kind of marketing message we had to send to the customers in near real time. Okay. So for that we have developed this particular real-time streaming platform. Let me quickly walk through this particular architecture diagram. So here from the left hand side, real-time transactional data is coming. So I can write real-time transactional data, RTT. Okay. And it was getting landed in on-prem Kafka cluster. So here I can write on-premise system, and this particular pipeline is in cloud, which is basically managed by AWS. Okay. And in on-prem system, we were having a Kafka cluster from Confluent, where the transactional data was getting landed in this particular Kafka topic first, and then using Kafka connector, which is basically a sync connector, we were dumping that data from this Kafka topic to our S3 landing layer, okay, which is basically acting as a data lake. Okay, so here I can write landing layer. Now from this S3, the incremental data we were consuming using Spark structured streaming, which is running in Elastic MapReduce service, that is EMR cluster. And in this PySpark code, we were basically applying different transformation also. Like for example, for IMPS category of transaction, one particular marketing communication message we might need to send. For UPI related transaction, maybe we want to send different kind of marketing message, right? So categorizing different transactions using simple filter clause in PySpark data frame, that we were doing here. Apart from that, sometimes customer apply DND in some particular channel, that is do not disturb, right? So we cannot send marketing message in those channels which are belonging to those customers. For example, if a customer is applied DND in email, then I cannot send marketing emails as per RBI guidelines to that particular customer. So DND check also we were doing in this Spark structured streaming, kind of joins with different tables and all, and finally it was giving output those eligible customer list with their email IDs. Okay, and that output data we were writing in another Kafka topic. Now our on-prem Kafka was managed by Confluent, but this cloud Kafka was managed by MSK, that is managed streaming for Apache Kafka, which is again another service provided by AWS. So here I can write topic 2. So this is basically topic 1 with respect to our data pipeline, which is in on-prem. Topic 1 is in on-prem. Topic 2 is the first topic in our cloud platform. And now what we are doing, from this Kafka topic, we were running a Kafka connector, which is again a sync connector kind of thing, I can say. Basically, this connector's responsibility was reading the messages from this particular topic and call the API, which is basically Salesforce Marketing API. We often call this SFMC, that is Salesforce Marketing Cloud. So this Salesforce Marketing Cloud has different APIs using which we can directly send marketing messages via various channels, that can be SMS, WhatsApp, push notification or emails, etc, right? So what this sync connector was doing, it was reading the messages, those eligible customer list, customer ID, their email address, phone number, etc., whatever required for marketing. Those informations the sync connector was reading from this Kafka topic where our Spark structured streaming was writing the data. And basically it was calling this Salesforce Marketing Cloud API with the customer information and the marketing message, whatever we want to convey to the customers. And that particular API was basically sending the SMS or WhatsApp message to those target customers. So here our customer is sitting, I can say. Customer was receiving SMS or WhatsApp, etc., right? So this is how our real-time pipeline was working, and it is not finished here. There is something more which you can see here. So what these components are doing, let me explain quickly. So whenever this sync connector call the Salesforce Marketing Cloud API, it obviously returns some sort of response. Now we need to store those responses as well. So this sync connector was writing those response information in another topic. So I can say it is topic 3. Okay, right? And from this particular topic, using another Kafka connector, which is S3 sync connector, we were dumping the data in another S3 folder, okay, which were basically storing the response informations, whatever we received after calling the SFMC marketing API. Okay, right? So this is particular pipeline which is basically only for response handling part. Now what this particular topic is doing, which we can say topic 4. So this was basically acting as a DL queue. For example, if the API is not reachable or API is returning some sort of error, then what we were doing, after maybe 2-3 times retry also, if the API is not returning success response, we were inserting those messages in another topic. From there again via another connector, we were dumping the data that these messages we were not able to process in the real-time process, and those informations we are writing in another S3 folder, right? From this particular folder, maybe data engineering team can inspect further that why the API failed and several other root cause analysis they can easily do. Okay, and in each layer you might see these kind of symbols like 1, then here again 1. So what this 1 symbol is basically depicting is shown here. It is basically a common template architecture that glue crawler basically crawls some S3 folder, then it update the schema in glue catalog, and from that catalog we can query the data using AWS Athena. So whenever our transaction data is getting landed from on-prem to cloud, here on top of landing layer we are having a glue crawler, and that is populating the catalog, and we were able to query the data using AWS Athena. Same goes for the response topic, same goes for the DLQ data also, which was getting landed in different S3 folders. So this is kind of our real-time data pipeline which was helping us in performing real-time marketing campaign. Now this whole process ideally completes within maximum 15 to 20 minutes post customer transaction. That means as soon as customer performs some transaction, the data comes in our banking Kafka cluster. From there it was going to cloud. From cloud, Spark structured streaming was processing it, writing the data in another Kafka, and then eventually this sync connector was calling SFMC API, and in real time the SMS was going. This whole process starting from customer transaction to customer receiving message, this used to take 15 to 20 minutes, kind of a non-functional requirement or NFR you can say for our this data pipeline, and it was running smoothly until one day we observed a huge delay in this data pipeline. And how this delay was observed, behind that also there is an interesting story. So generally if you observe here, the customers are spanned across the world. So customer is doing transaction anytime and they are getting marketing message. So even if it get delayed starting from 15 to 20 minutes, maybe if it takes 30 to 40 minutes, it is not a very easy task to sense for the data engineers or developers that the pipeline is delaying, right? But one day what happened, that one of our bank employee only who was involved in building this data pipeline, he has done a IMPS transaction, and that time after 40 minutes also he has not received any marketing communication message via SMS or WhatsApp. That time he raised the concern that is our data pipeline is having some sort of issue or it is somewhere getting delayed, and that time it was escalated because that employee was a senior member in our team. And then I got the responsibility to perform root cause analysis, that where actually the delay is happening, why it is not getting completed within 15 to 20 minutes. Okay, and after several hours of analysis, I found out that customer has done transaction maybe at 10:30 a.m. but the transactional information that the customer has done transaction, this particular event itself appeared in our Kafka cluster at 11 a.m. Okay, that means starting from customer's transaction to the data getting ingested in our on-prem Kafka, that itself was delayed by half an hour. And then after that the whole pipeline took only 10 more minutes, which is its default time. Okay, there is no harm in it, but the data itself came in our banking system late from the sources, and then eventually our banking team has communicated with the source system and they understood from the sources that it was a one-time delay in the source system. There was having some sort of issue which is obviously not controlled by bank, that is those sources are outside bank. So overall conclusion was, in this whole pipeline there was no such issue. In this particular layer itself, the event or the message was ingested with half an hour delay in our on-prem Kafka cluster, which is available within our bank, and that basically helped in resolving this particular escalation. Now the biggest question is how I was able to understand that the data itself came in our Kafka cluster with some delay. Let me explain you that particular process. So I have first observed the Confluent Kafka consumer lag, which we can easily inspect using various matrices provided by Confluent Kafka, and there I observed no failure or no delay. Then obviously next question will be checking when that particular transaction came in our landing layer in S3. Right now in S3 there are a lot of transactions because our bank was having more than 40 lakhs only saving account customer, then current account and much more NRI customers. Lot of different banking categories were there, so huge amount of transactional data was available. Now one particular transaction out of these huge data lake transactions, finding out when the file was written in S3 is kind of a tedious task. And that time this Athena metadata column feature basically helped me in detecting that. So Athena is having a feature called $path. Okay, very vital metadata feature which basically helps us in understanding from which S3 file basically this particular row in this table is coming from. And then what I have done, I have taken the transactional ID for that particular customer and I have queried in my Athena table, which was basically in turn querying our data lake itself where our transactional data was getting landed, and I have found out that from which S3 file that particular row is coming from, and I have inspected the time when the file was landed in S3, because in S3 we can easily see the last modified by for each files whatever is available in our S3 folders or bucket. So there I observed that the S3 file landing time was 11 a.m. Okay, but when I was inspecting the event what was available in S3 which was actually coming from Kafka, there the transactional time for the customer was written as 10:30 a.m. That means if in Kafka cluster overall there is no delay, then only delay possibility is from the source system, which is capturing that customer's actual transaction and sending to the bank server. There itself some delay happened. That's why it appeared in Kafka cluster itself late, and which in turn got dumped in S3 also late. So this Athena metadata column $path, which basically helps us in detecting one particular row is coming from which file, that saved me, or that basically helped me in performing RCA. Now let me show you that with one practical example also, how you can utilize in your data pipeline in some manner. So here for example, I am in my AWS account, and here in this bucket, in this landing layer test, I am having a folder called iris flower, and there 3 different files are available. Okay, now what I have done, basically first I am executing drop table command if it exists, because I want to create a fresh table, and I am creating a simple Athena external table pointing to our landing layer test iris flower folder. Okay, because it is a CSV file and it is having header as first row, I am ignoring the first row using this command, that is skip.header.line.count 1. Okay, right. Now if I do simple select star from iris dataset, here you will able to see 128 rows retrieved, and this is our popular iris dataset. If you have worked with machine learning or data science domain, you are very much aware of this, where first column is ID, then sepal length, sepal width, petal length, petal width, and based on that class names are there. Okay, So here basically in these files, in the Setosa file, only Setosa class are available. In the Versicolor file, only Versicolor class are available. And in Virginica file, only Virginica classes are available. Okay, that's how I have splitted the file. Now suppose you want to know this particular row is coming from which file from our data lake. That time you can use this particular command. Let me just zoom this little bit. Select star comma $path. Okay, I can maybe write this as path, one alias name I can provide, and from table name. So this is a hidden column in Athena, or metadata column you can say, just like in Snowflake external table we are having. And this basically gives me one particular column where it basically shows that this row is coming from which file from our S3 data lake. So ID is Virginica, this particular row is coming from virginica.csv, right? Suppose you want to know what all distinct files are contributing in the data in this particular table. That time you can simply execute select distinct $path from ID's dataset also, and you will be getting all the unique list of file names. Like here you can see versicolor.csv, virginica.csv, setosa.csv. Whatever we are having here, you can see that same dataset we are able to get here, right? So this $path is a very vital feature of Athena. I just thought to share with you with a real world scenario that how it can help you sometime in performing more detailed analysis. Like for example, I can show you how it helped me in my case. Like select star $path I have executed, and suppose this was the row where the customer escalated that he has received marketing message very late. Now based on transaction ID we can easily filter. Now suppose this is the file from where that transaction is coming. If I get this information, I can easily go to my landing layer and I can get the idea that okay, here itself the file came at 11:26. Maybe the customer has done transaction at 10 AM, but I can easily get the idea that when the file was landed in our data lake itself. And if it lands in our data lake after half an hour, then our pipeline or this real-time streaming pipeline has no fault. Then we need to inspect that whether in Kafka connector there is some issue or not. And if in Kafka connector also there is not much lag, there is no failure, then obviously from the source itself the transaction came late, right? As simple as that. So this is how sometime $path may help us in resolving issues in our data pipeline. Or maybe you can use this feature directly in building your data pipeline also in some manner. So this is what I wanted to share with you in this particular video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.